So today we're going to be looking at a technique called algebraic manipulation, and it sounds like it's basically just using algebra, but in more specific terms, more specifically, it means using algebra to make solving problems easier and quicker. And it's hard to describe it just like this, so we're just going to dive into the content straight away. So I'm going to write down a set of identities, and I assume for all people, any person doing competitive math, you should know these identities by heart. But really, you don't have to know these by heart. It's just very easy things to derive on the spot. So first, this. I think we all know this. And then we have this. And I think we all know this as well. And then we have this. Actually, I'm not sure we're going to use this, but I'm just going to include it here because, yeah. And then, okay, I'm just going to write this because you will need this for the next video. Actually, I'm not sure if I'm going to do a problem on this, but I'm just going to write it here because it's an important identity to know. So some people might not know this. If you do junior competition math, you might not know this, but it's good to remember. And yeah, I'm just gonna write down all the important ones. So yeah, all of you should know this. Well, I'm not sure about this one, but yeah, all of you should know these, and very helpful. And really, memorization is not a good thing in math. So I wouldn't say memorize these. I would say use these often in problems. Just find problems that use these, or just do a lot of problems, and you'll get to using them often, and you'll just remember them by heart naturally. That's the right kind of memorization that you should do in math. Or you should just, but you could also just derive it on the spot. So like, yeah. And I'm gonna write one more thing, which is, since if you look at these two, they both have x squared plus y squared. So what if we subtract x minus y squared from x plus y squared? Then the x squared plus y squared cancel out, and then 2xy minus 2xy is equal to 4xy. So yeah, this is basically just like in a rearrangement of these. Just like a combination of these, not a new thing. So you'll be wondering, why are we learning these again? Like, these are very straightforward things that all of us should know, and why are we going to be learning to use these again? These are so simple. Well, okay, I don't know when I'll make that video, but later we're going to learn harder identities that most people might not know, most people starting competition math might not know. But for now, we're going to use the ones that that most of us actually know, so that we can see the point of algebraic manipulation. So I'm going to give an example. So let's say the problem states that you're given that x plus y is equal to 3 and x times y is equal to 1. And the problem asks you to find x squared plus y squared. So what this means, so most of your approaches will be to simultaneously solve these equations to find x and y individually, and then plug them in, and then plug them into here to find x squared plus y squared. Well, that works, but you'll get a quadratic, and I don't think that quadratic is nice. I don't know actually, but like, that's kind of, if you're good at computations and stuff, then it might be quick, but some of you don't like that. So we're gonna find an easier way, which is, so look at this equation. So we know x plus y, we know the value of x plus y, and we know the value of xy. then we can see here, if we plug these values into this identity straight away, then we straight away get the value of x squared plus y squared. So if we know x plus y and we know x times y, then if we plug them into this equation, we can find the value of x squared plus y squared. So x squared plus y squared, oh, actually I'm just going to write it straight away. So 3 squared is equal to x squared plus y squared plus 2 times 1. So therefore, x squared plus y squared is equal to 9 minus 2, which is 7. So x squared plus y squared is equal to 7. So what's interesting about this is that we didn't even need to find what x and y are individually. We didn't even need to know what each of these are equal to, and we still found the value of the formula that we needed at the end. And this is actually a really good one. This technique is one of the best entrances, and provides one of the best entrances into competition math, because it introduces the concept of strategic laziness, which as AOPS calls it. And I call it that here because we don't even need to know what x and y are, and we just found the value of the formula. We were too lazy, so we used the strategy of finding an identity that just finds the value of this from this and this. So these identities are not just identities. We can now view them as identities that are relating different formulas, not relating different variables, relating different expressions. So it relates x, here we relate x plus y with x times y and x squared plus y squared. So if we know the sum of two numbers, and if we know the product of two numbers, we can find the sum of the squares of their numbers straight away using this formula. If we know the sum of two numbers and the difference of two numbers, we can straight away find the difference of the squares of their numbers using this formula. And then likewise, if we know the sum and the difference of two numbers, then we can find the product of the numbers using this. And then if we know the sum of three numbers, and we know the sum of their squares, then we can straight away find the sum of the products of every pair of them. So this is very neat. I can actually go, should I do another problem? No, I won't do another problem because it's pretty straightforward. But actually, yeah, I'll just do one more, just to clarify things a bit. So again, for this one, since most of us might not know this, x plus y plus 4, if we say that x plus y plus z equals 4, and xy plus yz plus xz is equal to 3, then we can get that. So we know x plus y plus z, and we know xy plus yz plus xz, so we can straight away find, and the problem asked us to find what x squared plus y squared plus z squared is. Then again, we don't have to find x, y, z individually. We can't even do that because it's 2 equations and 3 variables. Actually, but again, just plugging them into here, since we know there is a relationship between these expressions. So we just plug them in there. So 4 squared is equal to x squared plus y squared plus z squared plus 2 times 3. So this is therefore equal to 60 minus 6, which is 10. So there we go. Yeah, that was just a quick example to just clarify some things. So yeah, that's what you need to know for algebraic manipulation. And then, so these are straightforward problems. These just directly ask you, and if you know these, then you'll be like, oh, there is a relationship linking this, and this expression, and we just plug them in and we straight away get the answer. But now we have to move on to the next stage of trying to not just being straightforwardly given these, but just trying to make it on our own. So knowing what to do, in that situation. So we're going to look at some common problems that we can do in the next video. So this was just an introduction, but I hope this made you understand the concept of strategic laziness for the first time pretty well. And I hope to see you in my other videos.